Almost time. Well, let's kick it right on off. Good morning, everybody, and happy Thursday. My name is Brian, and I am the newest addition to the FDOT CAD Office Training Group. I'd like to welcome each and every one of you to the next session in our 2024 CAD webinar series. This morning, it's Bring Your Kids to Work Day. So hopefully, if you have children, you're incorporating them into this wonderful opportunity to see what everyone's parents do at work. So we have a robust program here at FDOT, and hopefully you have something going on where you are as well. Today's webinar will be on the FDOT. Let me look at that again. The FDOT Rebar Tool within FDOT Connect 10.12. Your instructor this morning is the lovely and capable Rebar Tool guru herself, Heather Pjorn, the lead structural engineer with WSP. I'll turn it over to Heather just momentarily to welcome and introduce herself, but first let's go over some housekeeping items. Please feel free throughout the training to submit questions you have to the go-to question dialog box. We may answer questions as we go along, and time permitting, we'll entertain questions and answer them in person at the end of the webinar. Really quick connectability issues with, I think it was almost 200 registered for this amazing training opportunity. Inevitably, a handful of y'all are going to experience some sort of connectability issues, whether you lose sight, whether you lose audio, something like that. It will happen. Please believe me, we are monitoring the performance and the operation of the webinar. So we are going. If you lose audio, one thing you could try to do is within the audio connection thing, toggle between phone call back to computer audio. Computer audio is the best way to do it. If that doesn't work, 99% of the time, disconnecting and reconnecting will fix your problem. But for that little 1% of the 5 or 6 of you that encounter this during this webinar, please know I feel for you. I just can't reach you. So, but we will be recording this and posting it to our training page as well. So, with that though, I'm going to turn it right on over to Miss Heather, and the floor is yours. Good morning.
Welcome to today's webinar on the FDOT Rebar Tool within FDOT Connect 1012. My name is Heather Pjorn. I'm a lead structural engineer with WSP and our Tampa office, and I'll be instructing the webinar today. So before we jump into the program itself, I want to give a brief history of the FDOT Rebar Tool. So pre-1990s, a version of the program existed as a card reader mainframe application. So it was brought forward from that card reader mainframe application to use with the first PC-based microstation applications in the early 1990s. So from there, the application remained mostly unchanged through the microstation Select Series applications. Then, when the Connect Edition software, so OpenRoads Designer and subsequently OpenBridge Modeler, as well as MicroStation Connect, so when that software was released, the new application was developed based on the old tools. So while the application itself looks different, it is very similar to the old FDOT Rebar tool from the Select Series days. So we will be using OpenBridge Modeler today for the demonstration, but I just wanted to mention that you can access this tool in any of the FDOT Connect applications, including MicroStation Connect Edition or even OpenRoads Designer, since it's just a part of the FDOT tab. I did also want to mention that the FDOT Rebar program is different than the 3D modeling of rebar using ProConcrete within OBM or using ProStructures. So that's a kind of a separate workflow. These tools can be used, or these programs can be used to develop an FDOT bar list, and that will be covered in a future FDOT webinar. All right, so let's go ahead and jump into the program. All right, so we're going to go ahead and sort of start from scratch here. So I've got a work set open within the FDOT workspace. If you're working on a project, you'll go ahead and have your project work set open. And I'm going to go ahead and open up the blank file DGN. So this is just to get into the workspace so that I can access the FDOT Create File tool. If you've already got a DGN that you've created within your workspace, you don't necessarily need to open this blank file DGN. You can just access the Create File tool directly up here in the top left. So once I open the FDOT Create File tool, the discipline that you want to use is structures. The file group that you're going to select is going to be just the structures sheet files here. And then you'll scroll down to the B pound rebar list. So we're going to go ahead and create the sheet itself, or the sheet file itself that the rebar list will be placed on. So while you're developing the rebar list itself, you don't need to have this sheet file open. You can, have any file open. But just to kind of get ahead of where we're going to place the rebar list once we've created it, I'll go ahead and create the sheet. So I'll just use B01 here. The output folder will be structures, that's correct. You can see that the seed file here is a 2D seed file. We don't need any 3D aspects for this tool. The county, I'll leave as Hillsborough, that's fine. And then the actions, I'm gonna actually go ahead and delete these. So what this would do if I didn't delete this is it would create a sheet model within this file automatically. So I'm going to go ahead and delete that because we can use the rebar tool later to create a sheet model. So when I hit create and open file, you'll see that blank file DGN is closing and this rebar list DGN has opened. So we don't need our create file tool anymore, we can just close this. So this is just a kind of a blank brand new file that we just created from a seed file. So now we're going to jump into the rebar tool itself. So again, we're in the FDOT tab. I am in OpenBridge Modeler, so then our OpenBridge Modeler workflow is where the FDOT tab lives. Within that FDOT tab, we've got this structures group kind of in the middle here. So there are a few different tools here. Today we're going to be focusing on the rebar tools. So the rebar tools, it consists of kind of two parts here. So we've got rebar chart and we've got rebar draw. So you can think of these as kind of your input and then your output. So your input is where you go through, tell it all of the bars, and then the output is where, the rebar draw is where you would then place it in the sheet itself. So I will go ahead and launch the rebar chart portion here. So you'll notice upon first glance that this doesn't visually look like we're used to the program looking, but you'll see as we get in there that it is, again, kind of the same, the same deal. So I'll go ahead and go File, New. So I've created, a new rebar list here. It starts just with some dummy information for a unit and subunit. So I'll go ahead and follow the instructions here, right-click to edit. So I'll select the unit, I'll right-click, edit unit. I'll go ahead and just call this end bend. So I'll hit save here, and now you can see that the text has changed to end bend. So if I click on this subunit, again, right-click to edit. So I'll right-click, edit subunit, and I'll change this to just be, we'll just say end bend 1 southbound. So you can see that there's a number required here. So if you've got a couple identical subunits, you can go ahead and just increment this as needed, and then just enter the rebar information for 1, and it'll automatically multiply it by the number required. In this case, we're going to just have a number required of 1. So I'll click Save here, and now you can see that that subunit information is entered there. So you can go through and organize this however you'd like between units and subunits. Obviously, it has that flexibility. So I'm going to click our subunit, and I'm going to start entering bar information. So you can see that these columns are similar to the columns that we're used to seeing. So I'll go in and I'll enter the bar size here. We'll say 8. I'll give it a designation of EO1. For number of bars, I'll just say 2. We'll start out with a nice and easy bar type here. So I'll use this drop down. I'll click 1, and you'll immediately see that once I selected that bar type, we've got this bar type graphic up here that opens up and it shows you, basically you've selected a bar type of 1. So where it's grabbing that graphic from is from the standard index SPI 415-001. So this is just our bar bending diagram here. So as you can see, for type 1, it went ahead and just grabbed this graphic and it's showing it to you. So that is very helpful, not necessarily for the easy bars, but as you get into the kind of more complicated bars, it going through and showing you what the bar type looks like and what variables are associated with it. That'll help you go through and fill out the variables and make sure that they match the schematic. So after I've entered the bar type, we're not going to have any varies bars in this case. There are no associated bends with this bar type. So I can just click on this B dimension here, and I can enter in our size here. So we've got 26 feet and 2 inches. So you'll notice that this little kind of sub application here allows you to enter bar lengths in feet, inch, and fraction of inch increments. So, unlike the previous tool where you would have to enter it as decimal feet, you can just enter it as feet, inches now. So I can either click convert or I can hit enter and it'll convert it directly. So you can use that convert. You can, I will say you can also just enter it in decimal feet within the feet area and then click enter and it'll do the same thing. So it's up to you. If you've got all the feet inches memorized, you can continue to work that way, or if you'd prefer, you can enter it in feet inches as well. So what you'll notice here on the right is that there's a kind of a status column here, and you can see it changed from red before to green. So this status will tell you when you've filled out all of the information, right? So for bars with more required variables, like sometimes n or theta sometimes get missed, the status will be helpful to let you recognize if a variable is missing. And also, as a heads up, you'll see, if you notice here when I was entering the bar type here, there is a comment line, so that comment line still is available. If I were to click on that, it would kind of gray out everything except for designation, and that's where you would enter your text for that comment. So in this case, we're going to keep our bar, our 8001 bar. So I'll go ahead and add in another bar type here. I'll just go through and enter various bars. So you'll see that I can also, for like the designation, I can hit tab on my keyboard and then it'll move over to the next column. So you can kind of tab through if you'd like. So for this one, I'll say it's a bar type 18. So you'll see again, when I change that bar type to 18, it's now telling me that the B dimension should be my my out to out dimension here, and then I've got a defined A hook and a defined G hook here. So since this bar has hooks, the A style and G style areas are now available. So we'll just give these type 3 bar bends. And again, this is very helpful because as you enter your bend here for style 3, it'll show you that this is just a 90-degree bend. And again, that corresponds. If we bring over our standard plans SPI 415001 sheet, that will correspond to our hook details over here. So again, that'll be very, very helpful for you as you go through and enter your different hooks. All right, so again, for this one we'll enter the same thing, but we'll do 26.16667. I'll hit enter here, and you can see it let me enter as decimal feet as well. And you can see once I entered that, it's now indicating that that row is complete. All of the input that it's expecting for that type of bar has been entered. So I'll just do a few more bars here to demonstrate a couple different things. So we'll have this, we'll have there be 8 bars here. So for the bar type for this one, we'll go ahead and select bar type 10. And again, it shows you the nice little graphic there. So in this case, let's go ahead and say that we wanted varies bars here. So previously I just left that blank because it was just, one bar length, one consistent length for all of the different bars. So in this case, we'll go ahead and say that we've got 10 varied sets. So you can see when I've got this row highlighted with my varied sets, we've now got different headers up here at the top. So we've got B, we've got B max, and then we have C in this column here, and then we have C max. So when you enter varies bars there, it will automatically change the header to that, B max and C max, so that you can go through and input what dimension it varies to and what dimension it varies from. So it'll go through and add as many variables that can be varied. So I'll go ahead and for B, I'll say 5, and then I'll say that varies to 7. And then for C, I'll just say that that's 1.5. And again, decimal feet or feet inches, and I'll just say 1'6". Again, same thing. So in my scenario, I'm saying that the B dimension varies, but the C dimension stays constant. And now you can see the status as complete. That's everything that I was expecting for that type of bar. So I will note that not every bar and variable within that bar is able to be varied. So I will say you can reach out to the FDOT CAD office if there is a bar or a dimension that you feel you should be able to vary that is not currently being accommodated. I will also note that there are a couple of issues within the FDOT Rebar program with FDOT Connect 1012 that should be fixed with the release of FDOT Connect 2023. So those issues are kind of on some lesser used bars, but if something comes up, again, feel free to reach out to the FDOT CAD office. So we'll go ahead and enter, I think 1 or 2 more bars here. So we'll say this is an EO4 bar. Number we'll say 24, type of bar we'll say type 4. We will not have any varies on here, but we'll put some different hooks on this bar here. So we'll go ahead and give it a 135-degree hook there for both A and G. So once you enter those, again, these nice little graphics come up, and then you can see visually that B is the vertical direction, and then C is the horizontal. So I'll go ahead and enter in just some values for these. We'll just say this is B. Actually, we'll do 1 foot 11 inches, and then we'll have this C be 3 feet. So now we've completed this bar. We'll do 1 more bar. We'll call this 6 EO5. For number of bars, we'll say 8. For the type of bar, we'll say 23 here. So again, very helpful. I don't have to toggle back and forth between my my bar bending diagram. So I can go ahead and for B, that's where I'll enter my 1.25 or 1'3". And then for C, I have the radius. I'll have that just be 3 inches here. And then for D, that'll also be 1'3" here. I'll hit convert, and again, all greens. So that tells me that the bar list that I've entered, everything is complete as the program would expect it. So we'll say that I'm done with my bar list here for this unit. You can add additional subunits. So if I go up to the overall unit here, I could right click and do add subunit. So I can go ahead and add another subunit. We'll say end bent 3 southbound, number required 1. So now I've got a second subunit. So I have my first subunit that has all of the bars that I just entered. Go ahead and delete that row. and then I'll enter just, kind of a dummy bar here. So 801, number 2, I'll do just a type 1 again, and we'll say this is 261667. So again, I won't go through and add a bunch of bars to this unit, but you can have, separate subunits within the same unit here. And another thing that I'll note is that you can, cut, copy, delete entry lines here. So I could copy this row, I could paste it here, I could delete rows here. So you just click on the entire row itself off here to the left, right click, and then, cut selected rows. Then you could click on a new row, right click, paste. So you do have those options there. So I'll go ahead and just delete this subunit. We'll go ahead and use our initial subunit moving forward. So again, this just depends how you want to organize your bar list. You could add, multiple subunits if you want. You could have, substructure, and you could have end bent be a subunit. You could have pier, and then separate it into, cap, column, footing, pedestals, stuff like that. It just depends how you'd like to organize and separate your bar list in case, multiple people are working on various bar list components, something like that. So it's flexible, and you can set it up how you see fit. So now that we've entered all this information, I guess the next question is, right, how do I save this? How do I access it again later? How do I make changes? So I'll say first, you do have to go File, Save As. So when I go File, Save As, you can save it obviously anywhere you want. I would recommend the engineering data folder. That's where we generally save our bar lists. So you may notice that the file type down here is an XML. So previously, the Rebar program used a .inp extension as the input. So again, that's a change. It's just a different file format, the way that it's saving it. So I'll just call this rebar list test 1. So I'll go ahead and save this rebar list here. It looks like we've got a bar with, or a row with nothing in there. So I'll go ahead and save that again. So where this saves on your C drive, within your C worksets, FDOT, whatever your workset is, within the structures folder, engineering data, you'll see that this XML file was just created. And that's where all the file information is saved. So as I go through, if I were to make changes to the bar list and I save it, it'll go ahead and just overwrite this XML file here. So after you have your XML file saved here, again, you can add unit, subunit up here if you'd like, within the same bar list if you'd like. So once you've got that XML file saved, you can go through and generate what's called a report. So that's up here on the top right here, this report button. So if I click report, it will ask me to save an Excel file. Right, so in the same location, I'll go ahead and let the Excel file be the same name as my XML file. That'll be the default. So I'll go ahead and hit save here, and it'll save this bar list in the form of a spreadsheet that is formatted. Right, so this functionality did not exist with the old tool, and it can be very helpful. You can use either third-party tools or the built-in MicroStation Place Table tools to directly link to one of these spreadsheets. We are currently working on setting up table seeds to use the MicroStation Place Table tool so that works a little bit better for you. But in the meantime, you can use a third-party app if you'd like to link to the spreadsheet, or you could go through and use the method that I'll show you in a little bit to place the table. So a couple things to keep in mind. One, this spreadsheet is not dynamic, right? This is all just kind of hard input text here. So if you do go through and modify your bar list, which again is saved in that XML file, it will not automatically update your spreadsheet. So you will have to go through and regenerate that report within the rebar chart tool. Another thing to keep in mind is it does generate that weight summary that we had previously with the other rebar tool. So it'll go through and tell you, how many pounds per subunit, number of subunits total, and it'll give you kind of the grand total in the bottom right there. So nifty little tool, but again, you just have to keep in mind this is at the end of the day just a spreadsheet, so you can enter whatever you want, and it would overwrite how it's generated initially. So I will go ahead and not save that, but we'll see again in that engineering data folder that we've got our XML file and we have our associated Excel spreadsheet here. So we now have our XML file and we have our spreadsheet generated. So before we start placing our rebar list into our sheets, I'm going to go off on a quick tangent about legacy input files. So say I was working on a project where the rebar list was created using the old SS10 rebar tool. How do I use that work that I did before, setting everything up in that .imp file? So we do have a functionality here to import. So if you go File, Import, you have two options. One is to import the FDOT box culvert files, so that's a .prn, and then the second option is to put together the legacy rebar file, or to input or import the legacy rebar file. So that's the one that I'm going to kind of demonstrate right now. So we've already saved our active XML file, so we're going to go ahead and just import. And I've got this bar list in .imp file here as a test. So if I open that up, you'll see that it will go through and it will create all the different subunits, all the different bar entries that I had on this project here. So you'll see that it actually added it as another unit. So if you wanted this to be a standalone XML, then you would want to do that in a new XML file. So let's actually go ahead and do that so that we're not mixing and matching here. So I'll go ahead and save this XML file, and then I'll create a new one here, and I'll just go directly to import this IMP file here, and I'll go ahead and delete this unit, the starter unit here. So now you'll see that we've got our unit 1 and we have all these different subunits here. So what you want to do is obviously kind of browse through all of your subunits that you made using the legacy program, and you'll want to make sure that the status shows as complete, and that nothing kind of got lost in translation there. So it looks like everything is good to go. We've got kind of all greens all the way across. So now that you have imported your .imp file, you can go ahead and save it as an XML so that it can work and be modified with the new rebar tool. So I'll go ahead and give this a name. I'll just call it rebar list test 2. I'll click save. So similarly to the one that we just originated in the new tool, we can go ahead and click report, and we'll let it generate this spreadsheet, and it'll open it up in the background here. So see, this one obviously was a complete bar list, so it has a lot more information here. So you'll see that, if you're used to working with rebar lists, you'll notice that this is probably too long for one sheet. But I'll show you that it does actually go through and it will kind of chop it up and break it into segments. So you could go through and do that manually if there was somewhere that you wanted to, have a clean break. You could save it as different XML files, or you can let the program kind of just, stop it at wherever the row limit is. So I will close that out, and I'll actually close out this the rebar chart tool. So now that we've got our two spreadsheets saved, we can move into our, the output portion. So for the output portion, I'll open up this rebar draw. All this is going to do is ask me to select my rebar output file. So first we'll go ahead and do our simple test spreadsheet that we had. So you'll notice that we're selecting the Excel spreadsheet as the output file. So this is not our XML file. This is the spreadsheet directly. So we enter the data, it saves it as an XML file, and then you generate the report being the Excel file, and then you use that Excel file with the rebar draw tool to create the sheet itself. So once I select that rebar list, I'll click open, and then we have the option here to input it in the DGN. So I'll go ahead and click input to DGN. So you'll see, I'll move this and close it out here. You'll see that it's created a sheet model here, right? So if I go into my models dialog box, you can see we've got our default model, which is just, our empty blank model. And then what was just created now is this rebar sheet 1. So it placed the table automatically in here. And again, something to note, as always, these are just lines, lines on paper here. So again, not dynamic. If you need to go through and change this, you will have to go through and regenerate the spreadsheet, and then kind of plop it in the table again, or in the sheet again. So like I said, if you use the Place Table tool or one of the third-party applications, you can link it dynamically to the spreadsheet so that you can kind of just update the spreadsheet rather than placing it again. So just, it's important to keep in mind how you generated everything. That way you know how you need to update it. So this, the sheet model here is just, a normal FDOT sheet model with the normal FDOT border. So you can, manage this border information like you would any other border. So for example, I'll take a look down here. If I were to open up here the plan set manager and I went to edit single sheet, you can see that by default gives you that option for top title, bottom title. So I'll put spaces in there just so that text goes away, and then I'll just give it a sheet number of just say B1 100. So you'll see when I click OK, it does go through and dynamically update that border information. So again, you'll manage the border information the same as you would on any other borders within FDOT Connect. So we'll go ahead and run one more time this rebar draw tool here. So I'll go ahead and browse, and I'll show what our kind of larger list looks like when we import it. So I'll select again the spreadsheet. I've selected the spreadsheet for our test 2, and then I will input into DGN. All right, so you'll see now if we take a look at our models that we now have our model with our short little dummy bar list that we created there, and then we've got 2 additional sheet models, and these, rebar sheet 2 and rebar sheet 3. Those basically cover all of the that long rebar list. So like I said, it did go ahead and cut it off, and it gives it the same header, and then just pastes the remainder of the table there. So, again, you can decide if you want to have, multiple sheet models for various rebar lists in one DGN file, or if you want to have them, broken apart. It's up to you how you want to do your model management. In theory, you could have, all of your rebar sheets in one DGN. But again, that means, only one person can be in the DGN at a time. So just keep that in mind in terms of limitations for, file access. If you're, in a pinch and you need somebody working on the end bent rebar sheets while somebody else is working on the pier rebar sheets, up to you. But MicroStation Connect does accommodate having multiple sheet models within DGN if you'd like to use that workflow. So I will give, I guess, just another note to reiterate about making changes. So, say I went through QC and I've got some changes I need to make to my rebar list. So I can launch rebar chart again. I'll file open. I can open up my rebar test here, one, and then, I'll go through and say rather than 26.2, this is, 26 even. So I've gone through, I've made these changes here, and now I want to save it first. So once I click save, if I go within the engineering data folder here, you'll see that the file type, the date modified has been updated from when it was originally created. So that's the first step. You save your XML file. You'll want to go ahead and regenerate that report. So I do want to, I want to replace the spreadsheet that was in here because this is the older version of it. If you wanted to save it off as, pre-QC, you could change the file name if you wanted. Go ahead and save it. It's going to let me know that it already exists. Do I want to replace it? I'll confirm, yes, I want to overwrite that spreadsheet. And now it'll open up a spreadsheet, and now we've got our 26 even rather than our 26.2. So if I close this out, I could go through and I could, again, if I had set this up with the place table tool or a third-party tool, I could go ahead and refresh this link. But since this is not a link, it's just, again, lines on paper, I'm going to want to go ahead and re-import this Excel spreadsheet here. So I'll do input into DGN, and it's going to go ahead and create a fourth model. So in this scenario, this rebar sheet 1 is the kind of the original version of this DGN, or sorry, of this input file. So if I don't need it anymore, I could just delete that sheet model. Are you sure you want to delete the model rebar sheet 1? Say yes. So by default, these go through and name the models, rebar sheet 2, 3, 4 sequentially. So I would recommend that you go through and you kind of change these to something that makes sense for you. And bent 1 southbound. Now we'll just say this is and bent 3 southbound, and we'll pretend that, well, I guess this will be and bent 3 southbound. We'll say 1 of 2. And then and bent 3 southbound, 2 of 2. So you'll see that down here in the bottom right, you'll see that the sheet title here, rebar sheet, matches the description. And again, that description kind of came in, automatically. So we can go through and change this to say reinforcing bar list 1 of 3. So if we change that, we'll go ahead and change it for the others. We'll say 2 of 3, and then 3 of 3. So you'll see when we make these changes in the sheet model description that it is automatically reflected in the sheet title within the border there. So that's for all 3 of these. So just something to keep in mind. Again, you want to use your model naming convention as well as your model descriptions to your advantage to keep everything organized and also to have the border be reflected accurately. So even though you can control this in the model description level, you can still go through with the plan set manager. If I were to go through and edit a single sheet, you can see that it's It's basically been reflected already, but I could go through again and, kind of delete the extra lines there. So I'll go ahead and do that real quick on these other sheets as well. Now you could go through and do edit multiple sheets, but since we only have 3, I'll just do them manually here. So you'll see now we've got these 3 sheets here, and they are all called reinforcing bar list. 1 of 3, 2 of 3, and 3 of 3. All right, so before we finish up, I want to talk a little bit more about varies bars and the spreadsheet formatting versus the formatting when you use the rebar draw tool. So let's go ahead and open up our example here, the one that we created from scratch. So you'll see here in row 7, we have the start of our varies bar here. So 7 and 8 are our 2 rows of varies bars, basically our min and our max. So it does show the size and the designation of the bar. So we've got our 8E03. It does show that it is a varies bar here in terms of the length, and it shows underneath it what the average length of the bar is. So 7.6 is the average length of our varies bar. But you'll see that it shows in number of bars, it shows as 8 bars. So this 8 is what we input as the number of bars, but keep in mind that varies bars also has associated with it a number of sets. So in our case, we had 10 sets of 8 bars, so that would be 80 bars total. However, that 10 component of the sets is actually stored way off to the side here. So if I zoom in over here, you'll see for row 7, it has a 10 off to the side. So this 10 over here represents the number of sets. So we have 10 sets of 8 bars here. So the information is in the spreadsheet. So we've got, 10 sets off to the side of 8 bars. So the information is there. However, you do have to keep in mind if you're going to be using the place table tool or a third-party app to directly link this spreadsheet rather than using the FDOT Rebar Draw tool. You'll have to keep in mind how the program handles varies bars in terms of formatting. So you'll more than likely have to edit this cell in order to give kind of the full information here. So I'll go ahead and change to the view in OBM, and we can see how it shows these bars in the version placed using the Rebar Draw tool. So this is our same table here, so it's pulling from the same information, the same data, but you'll see that it's formatted differently here. So here we have varies that 7'6", which is the average bar length, but then here it does pull 10 sets of 8 bars. And then for the type of bar, it just shows as type 10. But we have all of our information here to tell us that we have 80 bars total. So again, let me toggle to the spreadsheet here. So that's a little bit different, right? Let me go ahead and put these side to side. So here it kind of merges these 2 rows and it shows vary 7'6", vary 7'6", but then for the number of bars on the spreadsheet where it just says 8 bars and then 0 bars, here it pulls that information off from the side and tells you 10 sets of 8 bars. So again, something to keep in mind when or if you would like to try to sync it with directly with the spreadsheet rather than using the rebar draw, you have to keep that in mind for varies bars. So we are in discussions with FDOT regarding how this gets formatted and pulled in. So this is how it currently works with FDOT Connect 1012, but there's a chance in the future that we will have the spreadsheet version that's a little bit closer to the rebar draw version. So another thing to keep in mind in terms of formatting between the two, you may also notice that when it gets put into the rebar draw, we still have this feet, inch, and fraction of an inch column here, but you'll see that the rebar draw tool, when it formats it, it pulls the information from these columns here. So, you know, the 26-foot 0, it pulls that 26, but it puts a dash in between and then 0. And if we had a fraction, it would pull that fraction in here. Whereas, again, if you're linking directly to the spreadsheet, you'll see that it's basically 3 different columns here. So we've got column for foot, column for inch, column for a fraction of an inch. So it doesn't have the dash in between them and combine them into one, you know, cell visually. So again, something to keep in mind. If you're going to try to link it directly with the spreadsheet, it will be, you know, formatted a little bit differently. It'll give you the same information, but it will be in separate columns. So that is it for the distinction between those two. Another note that I wanted to point out in terms of the weight summary, which is something that is or has been fixed for in the development of FDOT Connect 2023. The weight currently up here, the total weight that it gives you or that it calculates internally, does not take into account the total varies bars. So in this case where we have 8 sets of 10 or 80 bars, so you would get the weight of the average bar, so 7'6", and you'd multiply that by 80. Currently, I believe the program only assumes that there are 8 bars, so it is actually missing, just for the weight summary again, it is missing that 10 component over here. So again, that has been reported and has been fixed for OBM 2023, but keep that in mind if you are using this weight summary tab that gets generated, that it currently does not handle varies bars properly. So that is all that I have for today. Any questions or any issues with the FDOT Rebar Tool program, please reach out to FDOT CAD office and they will be able to sort you out. Thank you very much for attending the webinar today, and I hope you found it helpful.
All right. Thank you, Heather. And thanks to everyone for spending your time with us today and watching our presentation, our webinar. We want to thank Heather for sharing her knowledge and being on top of the ball with all of the Q&A. We will have the recorded video and the Q&A document posted within about a week on our website at fdot.gov/CAD. You'll notice there's a new look to our web page, but if you look for the tile labeled FDOT CAD webinars, that's where you will find this webinar posted along with the Q&A and potentially future webinar offerings as we get those scheduled. So make sure you keep checking back for new ones and make sure that you're signed up for the contact mailer. So if we get new ones scheduled, we'll send out announcements for that to you. I think we've got the majority of the Q&A answered. And like I said, that will be posted along with all the answers in on the page when things are posted. So I think we are getting close to time, and I don't think that there's anything critical that still remains to be answered. So we'll get that posted for you, and we want to thank you again, and everyone have a wonderful day.